Hello everybody. So today we're in the second lesson, and yes, the class was a bit noisy the other day, so I wanted to record it so that everybody here could actually understand because there are a bit of choke points that may cause a bit of chaos in class. So now instead of using the voices of the students, now you're gonna use the comment section, which for some reason my monitor says that it's turned off. I hate you, YouTube, and the algorithm. Anyways, let's just start. So attraction is a force under the influence of which objects tend to move towards each other. So basically, that means, for example, if I have if I have some tissues and a table, right? That's only for example. If you move these two objects together, if they are magnetic, they will attract, and they will be into one piece. Just how you do it with glue. Repulsion, on the other hand, is the opposite of attraction. So if we use the same example, but now they repel, that means both the tissues and the table will not deal with each other. They will repel and not touch. I think I made a mistake with repulsion and repulse. Sorry. Anyways, what about compass? I'll let you guys answer it in the comment section. While you guys are doing that because of course I know. I'll just give you 5 seconds because you could just stop the video. Okay, let's just continue. Um, also, yeah, yeah. What are magnets? Magnets are usually metals, but they can be sometimes rocks. They have an invisible magnetic field around themselves, and attract other magnets and subspecial metals. The, these are these are um, um, iron and cobalt, and another metal we will find out. Yeah, very interesting, I know. What about magnetic poles? Well, these are two ends of the magnet, and these are where the magnetic field is the strongest. So you put a metal item on either of these poles, its attraction distance is the most, the furthest, because it is the strongest at that point. The North and the South Pole, self-explanatory, or you can just search it. But I'll let you guys have like 3 seconds to get this information. You can always stop the video though. Okay, that was 4 seconds, but okay. Magnetic, let's just skip that because it's basically an item that can be attracted by a magnet. So, uh, anyways, let's just start. Uh, let's find out if these items attract or repel. Magnets, yeah, magnets. Let's see. I'll just give you guys 5 seconds because you can always stop the video to answer. Okay, let's check your knowledge. Does this attract or repel? Yes, it is. It repels. What about this one? Correct, it repels. What about these two? Yes, these magnets are attracting. A compass uses magnetism. Which way does a compass always point? East, west, north, or south? You can choose more than one answer. Yes, that is right. North and south. Yes, it always points north and south. Because the compass will always give you the directions of north. It's used by sailors a long time ago when they don't have GPS or Google Maps. So be grateful that we have it. Or maybe not. Maybe. Anyways, is gold, a metal that magnets can't pick up. Yes, that's right. Gold is not magnetic. What about cobalt? Yes, you're correct. Cobalt does attract stuff. Oh, magnets do attract cobalt. This is one of the one of the three other things that attract magnets, which is, well, the next one is iron. So what about copper? That's right. It doesn't get attracted or repelled by magnets. What about aluminum? That's the hard one. Yes, that's correct. It does not get attracted by magnets. What about silver? Yes, you cannot get a magnet to attract it. What about steel? Yes, you're correct. It can get attracted by magnets. And what if you put a magnet near to a nickel? The element, not the denomination. Correct. It does attract the magnets. Anyways, what? So I'll give you guys, let's say, 15 seconds because you can always stop the video to fill this out. And then we'll answer it together, okay? Let's go. Okay, let's see your learning. So, magnets have two poles. Yeah, magnets have two poles. One is called the South Pole and another is the North Pole. You can do it any way you want. I just say it the South first. When opposite poles are near one another, they attract each other. That means the two poles push, they push together. That means the two poles attract. When two of the same poles are near one, oh yeah, this is sorry. The other is oh no, when two opposite poles are near one another, they pull together. That means the two poles attract. When two of the same poles are near one each other, they push away from one another. That means these two poles repel each other. Yes, you're correct. Okay. Anyways, I'll give you guys, let's say, 30 seconds to fill out because we're going to do this all at the same time. Wow! Let's see. Does a crayon float or sink? Yes, it sinks because it's heavier than the density of water. What about a pencil? Yes, it sinks because it's heavier than water. What about a coin or a penny? I actually caused an argument saying this. Yes, it sinks. What about a popsicle stick? Oh, you're so correct. It floats. A toy car, which it presumably is made of metal. Yes, it sinks. What about the cotton balls that you see every day? Yes, it floats. And this marshmallow. That's a hard one. Okay, it floats. I'm sorry. This worksheet, this is easy, so I'll just give you guys 15 minutes, no, 15 seconds, sorry, to do this. You can always stop the video if you wanted to. Now, go. Well, I think everybody here is finished. What 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 happens to the status of the leaf? That's right, it floats. What about the paper tube? Yeah, it floats. What about that plastic straw you see every day? It also floats. And what about the rest? Does it float or does it sink? Yes, you're correct. It sinks. Anyways, let's go. So, let's fill in the blanks. We're gonna talk about. I'm gonna do this immediately because why not? And I want to test everybody's skills. Also, you can always stop the video while I'm saying this. So, the sun is a star because it emits out heat, lots of heat, and light. What about the Earth? What is it? Yes, you're right. It's a planet. It spins or rotates all the way around itself once every 24 hours. Yes, that's a day on our planet. That's why a day is 24 hours. The Earth goes around what? In about one? Yes, the Earth goes around the moon in about 1 month. And and what? Oh, sorry. It was supposed to be the sun. I'm sorry. It's supposed to be the sun in about a year. That's 365.25 days. I won't cover about why is it 365.25 days, but it's why leap years exist. Anyways, the moon goes around the earth in about 1 month, not the earth going around the sun in a month. I apologize for this. How many times have you traveled with the earth around the sun? This is this is Well, this is just asking how old are you, so yeah. Because I do not know how to zoom in correctly, and because this is overhated because the pixels are so bad, I am not going to do the reading thermometer problem. This actually happened in the real lesson, so yeah. Anyways, the last lesson I didn't give enough information about simple machines. So, we're going to do it. The first thing you can see is the lever. So, if you see this arrow here, if you put some work to it, this is the fulcrum, right? The load will move. So, each of these simple machines have three important parts. The wait, nah. I shouldn't teach that too soon. I'll do it in a separate video where I cover around the fulcrum, the loads, and the work that is required. For now, we're just gonna assume that this is like a seesaw, and then when you put force here, this object moves here. What about this one? This is a wedge, but you need to make some force for this object to move up the wedge. So this girl is putting force to move this box up this wedge. See? There. Anyways, what about this one? The most simple, not really the most simple, but I think the most well-known simple machine. The pulley. If you move this string down, oh no, wait. If you can see here, this is I can't really see right now, but this is where we pull the pulley, and then it starts this to go up, which then moves a load, which this is how these flags can move up. What about this? Oh, oh no, yeah. Oh, wheel and axle. It's simple. You know those stuff whenever you go on the table and then you just roll that bar around in circles so many times and it's satisfying? This is what a wheel and axle is. In this case, it's used to be on a bicycle so that it moves the load here, which is a human. The wedge is simple. It is an object used to, wait. Oh yeah, this is an inclined plane. I apologize. This looks like a wedge to me, so I got messed around a bit. I'm apologize for lots of messing around. It's kind of late right now, and yeah. But anyways, continuing on, this is a wedge, and you strike the hammer down to break this log, and that's what a wedge does. It improves the quality of life by using this wedge. What about this? That's a screw. But what does it do? That rhymes. It's a screw, and what does it do? Well, it turns around to keep things safe. That's why whenever you see your dad, he sometimes he sometimes uses a screw to keep your house tight and not fall down. Well, that's another part, but a part of it's made of screws. Anyway, simple machine. No, I'm sorry, I have to continue. So, what? So, what happens when we heat a chocolate bar? I'm so sorry for the bad grammar. But what will happen if we heat the chocolate bar? Can you guess what happens? Yes, correct. It melts into hot chocolate. Not really hot chocolate, but better chocolate. What happens when we heat ice though? Yes, it turns into the water that you drink. And it is very tasty when you, that's why tasty, yeah. But that's why whenever you put ice into your mouth, you feel a bit of water coming into your tongue, and then a few minutes later, it's just nothing, and your mouth is cold. What will happen if we cool cooking oil? Well, it stays the same. Cooking oil is like an exception, but I've never seen a solid cooking oil. But I think there is going to be technology that supports hard cooking oil. If I'm a bit wrong with this, sorry. This is on what life usually works. What will happen if we cool liquid chocolate? Well, if we know that heating chocolate to makes liquid chocolate, then we should know that cooling liquid chocolate should make normal chocolate. What happens if we heat butter though? Yes, it turns into a liquid like here, and then you put your yummy food in. So different metals. What is this metal? Yes, it's silver. It's the second most valued metal according to like everybody, and and its chemical formula is AAG. I do know that you everyone here is not old enough to do it, but I'm just teaching extra infos, and also if I'm mistaken something, please don't mind. It's very low quality. What about the gold? What about this one? Yes, it's gold. I'm sorry I said it, but it is gold, and its chemical formula is AU. What about this brown thing? Yes, it's bronze, and its chemical formula is CuSN. So yeah, that's some things you should know about simple metals. So, what is the most common material that you usually see in your kitchen? A, paper, B, wood, or C, metal? Yes, that's correct. It's C. I do know some houses are made of wood, but in this case, let's say it's a brick house. What can metals usually be? Rough, smooth and shiny, or soft? Yes, it's smooth and shiny. It's not soft at all. If you touch a metal by yourself, it doesn't feel that soft, but it doesn't feel rough, right? Yeah. Which of the following is made of metals? Bicycle, a ball, or gloves? Yes, it's the bicycle. Which of the objects shown here can be made of metal? This book, this chair, or a bottle? Yes, you're correct. It's a chair. I do know bottles are made of metal, but in this case, this bottle is likely not a metal bottle. Which option given below has metal in it? Yes, it is the belt. And what among these can be made of metal? Yes, it's the umbrella. So I think from now on, it will be a bit harder for you to comprehend. I should have said this sooner, but in my opinion, from here on out, it will be a bit tough for some of you. Yes, I do know the Simple Machines worksheet was a bit hard, but it won't get harder since it is a lesson. So, which objects here are likely to be made from metal? Please do not color them gray, but just say the objects out. Yes, the key, the screw, this pan, this cheese grater, this paper clip, and this fork are all made out of metal. You can't technically say this is made of metal, but it's a wooden spoon. And this is where the hard part begins. Ooh. Anyways, why does sour milk smells badly? Because, well, it is an example of chemical change. What about, you cannot revert chemical changes. They are going to be there forever. Or if you try and revert it, it will still happen, but it's just going to be weaker. The product will be weaker than its usual form. But that usually will not happen. Sand flowing into an hourglass is an example of a physical change because you can just wait for another hour to flip it back. 3. The change of state from a gas to a liquid is an example of physical change. That's because because changing states is physical change because you can revert it back to the original state. What example here is physical change? Can anyone answer it down in the comments? Oh yeah, right. Let's just get this straight. I don't think any of this is a simple change because it's very understandable. So just have any ideas on physical change, please comment down below, or at least just tell me it in Zalo. Okay, let's continue. The melting of butter when it's let out in a warm room is an example of a physical change. That's because you cannot revert it. One of these are the following of example of a chemical change. Oh yeah, all physical change. Yes, all of these, A, B, C, and D. This is likely a trick question. An ice cream cone melting on a hot day is an example of physical change. Which of the following here describes as a chemical change? Yes, if you are already hinted by the image, okay. But it is a match burning. What happens when charcoal is burnt in a grill? What is it an example of? Chemical change. You're so correct. Homogeneous and heterogeneous mixtures. Homogeneous mixtures are really simple. They are spread in the same amount. You can see the consistency between these mixtures, right? This mixture. So the uniform distribution of particles are here: air, steel, wine, and rain. These are some examples. Wine was included because it's made out of grapes and it has the same amount of the consistent amount of particles. What about heterogeneous mixtures? Well, it has a non-uniform distribution of particles, which can be shown by ice water, cereal and milk, soil, and oil and vinegar. Here are all examples of non-uniform distribution. This is because um, these are different. These are in different consistencies. Oil and vinegar here in this picture. You can see the vinegar and oil are two different things having different consistencies. So this is a simple chart that I think you should take so that one day you will not regret it. A fire needs to start from oxygen, heat, and fuel. These three make what is known as the fire triangle. It will be important one day if you are interested in science or even just learning. Well, today's in quotation marks homework is just for you guys to fill this worksheet out and send it to me by Zalo. If you don't have it, well, just type it in the YouTube comments. I won't let anyone see it because I have a special mode on. Anyways, see ya everybody. I hope you have a good time. And I do know, and of course I have a disclaimer. It is a hard lesson. I do not expect for everybody to know everything. So any questions, please leave that on the comments, and that's all. Um, See you everybody. Also, there's gonna be a booklet which I already sent it on the Zalo, so check there. Anyways, see you everybody. Let's get to the next lesson. Let's see you in the next lesson. I'm so bad at endings.